The universe, with its countless galaxies, stars, and planets, has fascinated humanity for millennia. Yet when contemplating the cosmos, we also ponder its fate. What lies ahead for this vast expanse of space and time? This question has fueled intense scientific research and debate among astronomers, astrophysicists, and cosmologists. While we do not possess a definitive answer, several leading hypotheses offer intriguing possibilities. In this video, we will dive into these theories and the captivating narratives they present for the universe's ultimate destiny. The most widely accepted scenario for the universe's fate is the Big Freeze, also known as the heat death. This hypothesis is grounded in current observations and theoretical understanding. It postulates a future where the universe continues to expand at an accelerating rate, driven by a mysterious force known as dark energy. Imagine a cosmic vista where galaxies, once grouped closely together, slowly drift apart. Stars which once blazed with brilliance exhaust their nuclear fuel and burn out one by one. Over long periods of time, the universe becomes increasingly cold and dark. This bleak vision results from the relentless expansion, causing a phenomenon known as entropy to reach its zenith. Entropy is a measure of disorder in a closed system. In the context of the universe, it signifies the gradual dispersal of matter and energy to the point where interactions between particles become exceedingly rare. The universe in this scenario gradually reaches a state of equilibrium where no further change occurs. It's a state of cosmic stasis with no more stars forming, no more galaxies colliding, and no more cosmic drama. The universe, in essence, freezes in time. The idea of a universe locked in an eternal freeze might sound desolate, but it also has a certain elegance. It is a testament to the inexorable march of time and the fundamental laws of physics governing our universe. However, this is just one of the potential endings for the universe. Now, in the Big Crunch scenario, the universe's future is characterized by a reversal of its expansion. It proposes that at some point, the expansive force responsible for galaxies moving away from each other will diminish and gravity will take over. As a result, the universe will begin to contract, ultimately collapsing in on itself. Imagine watching the night sky as the galaxies slowly draw closer together. Stars that had been receding will now approach one another. Over billions of years, the universe will shrink, becoming increasingly dense and hot. Eventually, it might culminate in a singularity, a point of infinite density where all the matter and energy in the universe converge. However, there's a significant caveat to the Big Crunch theory. It relies on the assumption that the universe's expansion will eventually cease and reverse. While this idea was once a contender, it has fallen out of favor due to compelling observational evidence to the contrary. Observations of distant supernovae and the cosmic microwave background radiation have indicated that the universe's expansion is not slowing down, as one might expect in a Big Crunch scenario, but is, in fact, accelerating. This revelation has led to the proposal of a different and somewhat unsettling hypothesis. After this, the Big Rip is perhaps the most dramatic and cataclysmic of the proposed scenarios for the universe's fate. In this hypothesis, dark energy, the enigmatic force responsible for the universe's accelerated expansion, continues to grow stronger over time. As it intensifies, its influence on cosmic structures becomes increasingly profound. Imagine a universe where the very fabric of space itself is stretched to the breaking point. Dark energy, which was once a subtle player in cosmic dynamics, becomes so dominant that it tears apart galaxies, stars, planets, and even atoms. Atoms, the fundamental building blocks of matter, disintegrate as the force of dark energy overcomes the binding forces that hold them together. In this nightmarish vision of the universe's end, not even the most robust cosmic structures are spared. Galaxies, those sprawling islands of stars and gas, are ripped apart into individual stars. Eventually, even stars are torn asunder, leaving behind nothing but a cold, dark void. While the Big Rip is undeniably dramatic, it's also one of the least favored scenarios among cosmologists. This is partly because it relies on the assumption that dark energy will continue to increase in strength indefinitely, a concept that challenges our current understanding of the cosmos. Moreover, the Big Rip would imply that the universe's ultimate fate is a sudden and violent one, a prospect that can be unsettling. Also, the Big Bounce theory presents a more optimistic outlook on the universe's destiny. It suggests that the universe undergoes a cycle of expansion and contraction, akin to the rhythmic rise and fall of a cosmic tide. This cyclical model posits that after the universe reaches a maximum size, it begins to contract, eventually leading to a big crunch. But instead of being the end, this contraction phase initiates a new cosmic birth, a Big Bang, and the cycle begins anew. Picture a universe that expands and evolves, creating galaxies, stars, and planets. Over eons, it reaches the pinnacle of its expansion, after which gravity takes control, causing it to contract. As it contracts, all the matter and energy in the universe converge into an incredibly dense and hot state, resembling the conditions of the original Big Bang. Then, a new cosmic era is born, with a fresh cycle of expansion, evolution, and ultimately, contraction. The idea of a cyclic universe is intriguing because it potentially sidesteps the question of a definitive end. It suggests that the universe is in a perpetual state of renewal, a grand cosmic cycle that continues indefinitely. However, it's important to note that the Big Bounce theory is far from proven. While it has garnered interest and mathematical support from some researchers, substantial empirical evidence is currently lacking. Additionally, this theory raises questions about how the universe's past cycles might connect and how information and entropy are conserved across these cosmic iterations. The ultimate fate of the universe remains one of the most intriguing questions in cosmology. The leading hypotheses, Big Freeze, Big Crunch, Big Rip, and Big Bounce, each offer a unique narrative for the universe's destiny, ranging from quiet stasis to cataclysmic transformation to eternal rebirth. These scenarios are products of our current understanding of the cosmos, built upon centuries of observation, theoretical insights, and mathematical models. So when we contemplate the fate of the universe, we are talking about something that extends far beyond the study of astrophysics and cosmology. It is a journey into the very essence of our existence. These laws, the fundamental rules governing the behavior of matter and energy, underpin the entire universe. They are the universal language that scientists use to decipher the mysteries of the cosmos. Whether we're exploring the furthest reaches of space or studying the tiniest particles in particle accelerators, it's the laws of physics that guide our understanding, revealing the harmony and order that exist in the seemingly chaotic expanse of the universe. No matter which scenario ultimately proves accurate, whether the universe ends in a quiet, frozen equilibrium, a dramatic cosmic collision, a catastrophic tear, or a never-ending cycle of rebirth, the very act of seeking answers to these questions is where it's at. And that brings us to the end of this video. What do you think? Which theory might actually be true? Will the universe really come to an end? Let us know in the comments below. If you liked the video, make sure to hit the like and subscribe buttons to stay tuned.